Hey everyone, welcome back. Glad to see you ready for another deep dive.
Always ready.
Okay, perfect.
Yeah.
And looks like we're diving into some fascinating stuff today.
Yeah, definitely. Probabilistic supply chains, demand forecasting, all that good stuff.
You know me, I love a good algorithm.
Uh-huh. Right.
And this time around, we're taking a deep dive into an article by Dr. Marcos Cisfontes Monge.
A real expert in this area. He's done some amazing work with SAP IBP.
Absolutely.
Yeah.
And he even compares optimizing a supply chain with SAP IBP
Oh,
to
yeah, to cracking the Enigma code.
exactly using algorithms to make better predictions, smarter decisions. It's incredible.
I mean, that's really the heart of it, right? Using data science to win the supply chain game. It's like a whole new world.
Totally. And we hear so much about AI and machine learning these days.
ChatGPT, DALL-E, it's everywhere you look.
It really is. But today we're focusing on how SAP is using those same technologies.
To handle that uncertainty that's always present in supply chains.
Right. Because let's face it, predicting the future is never easy.
No, it's not. And that's where SAP IBP comes in.
Yeah, Dr. Cisfontes Monge, he's a big believer in its power.
He is. But he also warns about some potential pitfalls.
Because it's powerful stuff, right?
Oh, yeah, incredibly powerful. But it's like having a high-performance race car.
You got to know how to handle it.
Exactly. If you don't, things can go very wrong very quickly.
He actually shares some real-world examples of companies that didn't quite get it right.
He does. There's one case study that really stands out, a large beverage company.
I think I remember reading about this one.
Yeah, they ended up with a 550 million sales difference in Europe alone.
Wow, 550 million, that's a lot of money.
All because of a single misjudgment by one of their architects during the implementation process.
Ouch, that's gotta hurt.
It does. It really highlights how critical human expertise is, even with the most sophisticated technology.
You can't just rely on the algorithms to do all the work for you.
Exactly. And there are other examples too, an oil and mining company that ended up with way too much inventory.
Oh yeah, like 90% more than they needed,
Right. And a pharmaceutical company that got bogged down with data overload.
which actually ended up hurting their system's performance.
It did. And it just goes to show poor implementation can really undermine the potential of SAP IBP.
It's not a magic bullet, you have to use it the right way.
Exactly. But when it's done right, the results can be incredible.
Oh yeah, he has a case study in the article that proves that point.
It's about this company that was stuck using over 100 Excel spreadsheets for their planning.
Can you imagine? 100 spreadsheets?
It's mind-boggling, and all that manual work was actually costing them a fortune.
I think they were over forecasting by something like $85 million.
That's not exactly pocket change, so they were definitely ready for a change.
What they had already tried SAP IBP twice before.
And it didn't go so well, right?
Yeah, two big consulting firms tried to implement it and failed.
So they were understandably skeptical.
Okay, so they're facing this challenge. They need a better way to forecast, but they've already been burned twice.
Right. So what did they do differently this time? They focused on a key metric, WMAPE.
WMAPE, weighted mean absolute percentage error.
Yep, that's the one. It's commonly used in supply chain management because it takes into account
The relative importance of different products, right?
exactly a 10% error on a high volume, low margin product.
Isn't as impactful as a 10% error on a low volume, high margin product.
Precisely. WMAPE helps you capture that nuance.
That makes sense. So how did they use this WMAPE to actually improve their forecasting accuracy?
Well, they didn't just plug it into SAP IBP and cross their fingers.
No, they needed the human element.
They brought in a team of experts, people who really understood both data science and supply chain management.
So they could bridge the gap between the technical and the practical.
Exactly. These experts were able to fine-tune the algorithms within SAP IBP.
And develop a customized approach that really works for this company.
It was impressive. After implementing these optimized algorithms,
They achieved an overall WMAPE of 12%.
which translates to 88% accuracy across their entire product portfolio.
88%, that's amazing. Talk about a turnaround.
It really shows what's possible when you combine the right tools, the right expertise, and a data-driven approach.
I love it. But you mentioned the Enigma code analogy earlier.
Yeah, Dr. Cisfontes Monge really drives home that comparison in the article.
Comparing optimizing supply chains to breaking that complex code.
It's brilliant, isn't it? He's basically saying that
Just like the Enigma code was incredibly complex and constantly changing.
supply chains are also incredibly intricate, with countless variables and shifting dynamics.
It's like trying to solve a puzzle that's always changing its pieces.
And just like Alan Turing realized that only a machine could defeat another machine.
Sometimes you need the power of sophisticated algorithms to truly optimize your supply chain
It's mind-blowing, really. These algorithms can analyze huge amounts of data.
and find patterns that humans would never be able to spot.
It's like having a superpower.
But it also makes me wonder, do you need to be a data scientist to use these tools effectively?
Not necessarily. There are definitely some technical aspects to it.
But you don't need to be a coding genius.
Exactly. The key is finding the right partners, people who understand both the data science side.
And the supply chain side.
They can help translate that technical jargon into practical solutions that you can actually use to improve your business.
So it's more about finding the right team and the right tools.
Then trying to become a data scientist overnight?
Okay, that's a relief. But I'm still curious about the secret sauce behind that case study company's success.
Ah, yes, the secret sauce.
Dr. Sisvantes Monge doesn't reveal the exact algorithms they use, does he?
He keeps it a little mysterious.
But he does offer some clues, right?
Yeah, definitely. He mentions that SAP IBP supports a whole range of forecasting algorithms.
Each with its own strengths and weaknesses.
And he also hints at the possibility of integrating external algorithms, like something called FB Profit.
Which runs on platforms like Amazon, AWS, RStudio, and Python.
It's like having a secret weapon in your forecasting arsenal.
I love it. So are you telling me there's no one-size-fits-all solution when it comes to choosing the right forecasting algorithm?
Absolutely not. Every company, every product, every data set is different.
So you need that expertise to really analyze your specific data.
And understand your business goals.
It's about finding the perfect blend of human intelligence and artificial intelligence.
That's what it all comes down to.
This is fascinating stuff. I feel like I'm already getting a better grasp of this whole probabilistic supply chain world.
Me too. It's definitely a game changer.
But we've only scratched the surface, haven't we?
Oh, absolutely. We still need to dive into those specific algorithms that Dr. Sisvantes Monge mentioned.
And figure out how they actually work.
That's what we'll pick up in the next part of our deep dive.
Sounds good to me. I'm ready to learn more.
Me too. It's going to be exciting.
I can't wait. Okay, so we're all in on this probabilistic supply chain thing. But what does it actually mean for businesses? How can we use this idea to our advantage?
Well, it all boils down to how you approach forecasting and making decisions. With traditional forecasting.
You're trying to predict a single number, right?
Yeah, like we'll sell exactly this many units next month.
That's right, a deterministic prediction.
But with probabilistic forecasting, you're acknowledging that the future is inherently uncertain.
So instead of trying to be exactly right,
You're looking at a range of possible outcomes and assigning probabilities to each one.
so let's say instead of saying, we'll sell 1,000 units next month,
You might say, there's a 60% chance we'll sell between 900 and 1,100 units.
a 20% chance we'll sell less than 900, and a 20% chance we'll sell more than 1,100.
That's it. It's about understanding and quantifying risk.
So you can be more flexible and adapt to changes in demand,
You can adjust your inventory levels, make better production decisions.
and hopefully avoid those stockouts or having too much inventory.
Exactly. But how do these algorithms actually work? You mentioned different algorithms.
Each with its own strengths and weaknesses.
It's right. It's like having a toolbox full of specialized tools, each one designed for a specific job.
Okay, so like a hammer is great for nails, but not so good for screws.
Precisely. And you wouldn't use a screwdriver to hammer in a nail, would you?
Definitely not.
Yeah.
So let's open up that toolbox. What are some of these forecasting tools?
Well, a simple one to start with is single exponential smoothing.
That sounds pretty basic.
It is, but it's a good starting point for data that doesn't have a clear trend or seasonality.
So it's adaptable to changes,
It gives more weight to recent data points.
like looking in the rearview mirror while driving. What just happened is a good indicator of what's next.
You got it. Now, if you do see a trend in the data,
Like sales consistently increasing month over month.
you might want to use double exponential smoothing,
This one takes into account both the level and the trend.
making it more suitable for products that have a consistent upward or downward movement.
Okay, got it. What about products that are seasonal, like those pumpkin spice lattes that pop up every fall?
Yes, the pumpkin spice effect. For products with strong seasonal variations, you'd use triple exponential smoothing.
Also known as the Holt-Winters method.
Yep, that's the one. It factors in level, trend, and seasonality.
So it can handle those predictable spikes in demand.
Exactly. but those are all exponential smoothing algorithms.
What if we have more complex patterns that don't fit neatly into those categories?
Then it's time to bring out the big guns. ARIMA models, short for Autoregressive Integrated Moving Average.
Arima, now we're getting serious.
They can capture really nuanced patterns in the data.
By looking at both past values and past errors.
It's like a detective using clues from the past to predict the future.
Okay, I see what you mean. But what if I don't have a PhD in statistics? Any simpler options for more straightforward patterns?
Sure, there's always multiple linear regression.
That rings a bell.
It's a classic statistical technique that's great for forecasting when you have multiple factors affecting demand.
For example, if we wanted to predict how much hotter pumpkin spice latte sales would be based on the temperature outside.
That's the idea. You could use it to model the relationship between sales and variables like price, promotions, or even the weather.
So it sounds like there's an algorithm for every situation. But we can't forget about data quality, right?
You're absolutely right. Even the fanciest algorithm is only as good as the data you feed it.
Like that old saying, garbage in, garbage out.
Exactly. You need accurate, complete, and consistent data.
So data cleaning and integration are crucial.
It's like spring cleaning for your data, getting rid of the clutter and making sure everything is organized.
Clean data, check. Anything else?
Don't try to do too much at once.
Start small.
Pick a pilot project, maybe a product line with a lot of historical data.
And then start experimenting.
See what works. Learn from your mistakes.
And slowly expand from there.
That's the way to go. It's a journey, not a sprint.
Speaking of journeys, Dr. Sisvantas Manji's company, Aurelius Enterprises.
They seem like the perfect guides for this data-driven adventure.
They've got the experience and expertise.
To help you navigate the complexities of probabilistic supply chains.
And unlock the power of your data.
Definitely worth checking them out.
All right, we've covered a lot today. From the big picture of probabilistic supply chains to the nitty-gritty of forecasting algorithms.
And we even touched on some practical tips for getting started.
But how can our listeners actually put all this knowledge into practice? What steps can they take to really embrace this whole data-driven revolution?
That's a great question, and one we'll definitely address in the final part of our deep dive.
Okay, so we've talked about probabilistic supply chains, SAP IBP, and all those forecasting algorithms.
A lot to take in, right?
It is. But I think the big question everyone's asking is, how do I actually use all this? What can our listeners do to make this data-driven forecasting work for them?
Well, you don't need a magic wand or anything.
That's good to hear.
The first step is just being honest about where you're at.
Like, are we still living in spreadsheet land?
Exactly. If you're still relying on spreadsheets and gut feelings for your forecasts,
it might be time to step up your game.
Consider those tools we talked about, like SAP IBP and cloud solutions.
Ones that can integrate with your existing systems.
Right. But remember, it's not just about the tools themselves.
You need the know-how.
It's like having a fancy new oven.
But not knowing how to cook.
That's a good analogy. So find the right tools, find the right people, and don't forget about data quality.
Because garbage in, garbage out, right?
Absolutely. Your data needs to be clean, accurate, complete, and consistent.
Invest in some good data cleaning and integration tools if you need to.
Think of it as spring cleaning for your data.
Get rid of the clutter. Make sure everything is in order.
Exactly. And one more thing. Don't feel like you need to do everything at once.
Start small. Pick a pilot project.
Maybe a product line with lots of historical data.
Experiment, learn, and gradually expand your efforts over time.
It's a journey, not a race.
And Dr. Sisvantas Manji's company, Aurelius Enterprises, they sound like they can be a great guide on that journey.
Oh yeah, they've got the experience and the expertise.
To help navigate those tricky probabilistic supply chains.
And help you really unlock the potential of your data.
Well, we've covered a lot today. Probabilistic supply chains, forecasting algorithms, even some practical tips.
We even dipped our toes into the world of data science.
I think the main takeaway here is that this isn't just a trend, it's the future.
Probabilistic supply chains and data-driven forecasting are here to stay.
And the companies that embrace this change?
They'll be the ones leading the way.
So to all our listeners out there, the future is probabilistic.
Don't be afraid to challenge the status quo, experiment, and find the right partners to help you.
It's been a fantastic deep dive.
I always enjoy these conversations.
Me too. And to everyone listening, thanks for joining us. Keep learning, keep exploring, and keep pushing the boundaries. Until next time.